Zero-touch activation, so this is what we'll be going to discuss in today's session. So if you see the diagram here, you would have realized that there is a secure home with a smart or a wormhole. So what it means, even though you have a very secure environment or a secure smart home, if you leave something, a very a loophole or something, then people can enter, breach into that. So actually, I should have replaced this with a fish tank. That would have made more sense. So before going further, our previous speakers from Verizon, they spoke about the strategy that we are following, how we have evolved from offering products to platform, and how we are moving towards offering application SLOs. So I'll touch base what we did to achieve and go further in that strategy. And also, in another session, we have seen end-to-end orchestration, end-to-end automation, what are the different tools we were using, and what were the value adds from each and every tool. I'll touch base those aspects as well. And finally, I will cover what we have done as part of automation. I will not try to boil the entire ocean, but take a very small use case or a simple workflow, and I will describe what are the various steps of automation involved in it, and finally, how we have thought about security, giving it a high priority. So that's pretty much. And as you can see, this is the evolution of our product offerings. From past 2 years, we started offering digital solutions, digital products. And not only that, we have evolved internally. We have digitally transformed ourselves to make sure we offer the right solutions to the customers. So we are not going in a typical monolithic implementation of our control stack. We have Dockerized it, used Kubernetes, made sure it is modular enough. And by that, what we got is a benefit. We created a microservice, and that was able to, we were able to make it useful for other groups within Verizon to consume that. So that's the biggest benefit of evolving and creating an API-centric architecture. That was the most value benefit. So in yesterday's session, Srilashmi covered how we were using Service Designer for sales to talk to customers and make sure the right design is adopted. And she also covered how we were using blueprints to create the network designs and make it available for the sales engineers to consume it and expose them to customers. So if you stitch these dots together, what it means is we created a blueprint for design engineers. They come in, drag and drop all the network functions, and from that, they generate the day zero config, heat templates that can be consumed by the orchestrator to go and instantiate them. The same blueprint is also exposing that design to the sales portals like Wisdom that we have created. So sales can show the design to the customers, and based on the customer needs, pick the right design. So your automation has started right from the customer enablement, customer onboarding, or customer buying the services. You get to know what exactly is required to instantiate and deploy. This was what we have done when we have created virtual network services. Viraj, in the previous session, he mentioned how we were able to deploy services into 1,000 sites in a very less time. Earlier, it was taking 12 weeks, and we were able to get down them to few hours. So I will also cover what steps we have taken to ensure that scale is achieved for our deployments. So the next evolution was Greybox, where we started shipping proprietary hardware to customers and launch network functions in it. So it is overshadowed because the advantage that you get with the white boxes, where it's a generic x86 hardware, and we host the customer network functions in it. Going forward, we should also think about how we should automate, bring your own hardware and bring your own software concepts. Like customer can bring in their existing hardware, and we have to make sure the virtualization is enabled in it. Based on what the customer asks in the service designer, we already know what is the requirements for that service to run in the hardware. So we can immediately say that, customer, what are the services you want? So we know what VNFs are required for that service offering. And at the same time, if customer also tells that I have this hardware, we can obviously tell, if that services can fit in it. And of course, he should have much more capacity to add on more services into the same hardware later. But the automation has to consider, is that hardware feasible enough? Virtualization is enabled in it, number of resources like CPU, memory, disk, is it good enough for the services? We have to do all that evaluations before onboarding the hardware. So for the white box, to my previous comment that how we were able to deploy it at scale, we have used our blueprints, and when the customer order came in, we get to know that, and we have followed, in the next slide I will be showing up, we have followed a sequence of steps to deploy these network functions. So this is the use case I was mentioning. Instead of going through entire automation workflow, I just picked up what we did for white boxes, how we were able to zero-touch provision that white boxes. So the initial challenge is, initial step is the bootstrap the bare metal, how the OS has to be baked into it, and the drivers required for the LTE radio or physical ports or any hardware drivers has to be installed. That's a first step anyway. And in traditional model, what you do is you ship that hardware to the customer location, and our technician would install the software, required software, and he would maybe he would be carrying a list of VNFs to install in it, and he has to figure out how the networking has to be done, which customer's preference of which port should go as LAN, which port should go as WAN, or how many WAN ports, so IP addressing them. These are all the challenges that traditional operations would take care of. But with the ZDP, we are able to pre-configure everything because we know what is that customer's services, VNFs required, what port he wants to use as LAN, WAN, because that network template got in agreement with the sales and customer. We know all of that beforehand. So we provision that and then ship it to the customers. So, second thing is the configuration of the VNFs. So now in the traditional mode of operations, customer has to install the VNFs and of course push the day zero configuration into it, and it's more error prone. But with ZTP, zero touch provisioning, we have eliminated the errors, user errors, human errors. And everything is from the control stack that is residing in our MSP clouds. So we push the VNFs remotely after the activation is done. Of course, I'll be covering the steps how securely we should do the activation. So our control stack can push the VNFs into it and configure it remotely. And of course, the instantiation configuration is fine, but there are runtime operations that we should also automate, such as updating the VNF. If there is a new version, how do we upgrade the VNF? And if there is a bug, how do we patch that VNF? So all these steps we were able to automate with our zero-touch provisioning mechanism. And we do regular monitoring of that VNFs that are deployed in the Whitebox. So we not only do at a hardware level, we do have troubleshooting APIs and diagnostics API, so we can figure out what exactly was the problem at the customer location. Is the hardware not responding, or is the physical port is down, or the VNF is malfunctioning, and at the same time, is it the VNF internal errors, like the session table overflowing, or memory issues within the VNF? So we monitor all types of events, not just from the hardware to the VNF. All events are monitored remotely, and so remediation and healing the issues are all automated. So these are the various stages that we have considered for our zero-touch provisioning. So now the next thing, so let's say a customer has bought a Whitebox and it was on the way to the customer location. The Whitebox has fallen down from the truck. So if anybody gets hold of that Whitebox, since it is, if there is no security properly configured in the Whitebox, it becomes like your fish tank in the casino. So anybody can take that advantage and get into that Whitebox, and ultimately they can get onto our network, and from our network they can spread to other customers also. So when we are doing any automation, we have to give security as a top priority. So, I'll be talking about the workflow in the next slide, but so what are the key elements that we need to protect? We need to protect our control stack. We need to protect the Whitebox. So Whitebox generally, for our virtual network services offering, we provision VNFs in our cased environments, in our cloud platform. But Whitebox is something that is shipped outside, and it's not in a secure physical environment that we have for our data centers. So we need to ensure the security is baked in, and the key data that we are pushing in, like the license keys, the VNF images, or customer key information that we push it onto the Whitebox must be secured. So anybody, even if they were able to get into the Whitebox, they should not be able to gather that customer information or the license keys. That's the one key aspect. And also, these Whiteboxes needs to securely access our cloud controller stacks. Any company, any big company like Verizon, we have very strict rules. We cannot, place a public-facing application with a public IP so anybody can reach it. It's not good. So we host all of our control stack in DMZ and with the internal network. So how does Whitebox reach out to our servers? It's a challenge. And so in the next slide, where I will be presenting the reference architecture, I would be showing the solution on how we have addressed it. So a few days back, Microsoft Azure has announced a product called Azure Sphere for IoT devices. So the key thing that they mentioned actually applies to Whiteboxes as well. The same security requirements applies to Whitebox as well. They created a very lightweight Linux. This is the first time Microsoft is selling Linux, I believe. I may be wrong, but they are offering a simple, lightweight Linux in the IoT platform, in the IoT devices, which is hardened for for security. And they also included Trusted Platform Module, TPM. Microsoft was using TPM from long time. They were storing the license keys for your personal computers. They would be using that BitLocker to store the license keys. So they make sure the intention here is the license key that they are selling is only intended for that device. So here in IoT security or Whitebox, it's the same thing. Whatever I want to send data to that entity, or Whitebox, it must be only decrypted by that Whitebox. So using Intel's trusted platform module, a public and private key pair can be generated, and the public key, if it is provided to the Verizon stack, it encrypts with that public key, and the device which is receiving the data, it has the private key, but that private key is not in the file system, in a regular file system like any of us expect so, but it is tightly coupled into the hardware. So only that Whitebox can decrypt the data and receive the content in it. So by this, we can enable remote attestation of the Whiteboxes. It applies for 5G also in the base stations, in the virtual base stations, if we want to install operating system remotely, and if we want to make sure the workloads that we're pushing onto that node or hypervisor is only entitled to run that on that, you need these security mechanisms. So using TPM, you can build that remote trust and remote attestation workflows. So at the same time, we should also think about the network segments. So if any compromise happens on the Whitebox, as I said, they are connecting to our control stack in the cloud. We don't want that compromise to spread across multiple customers. So we need to ensure we have a segmented approach. So all the customers' Whitebox are entitled to talk to only respective servers, and they are not, the entire network should not be exposed. So this is an workflow that we have created to ensure the Whiteboxes are secure enough. So there are mainly 4 key players here. The OEM, who is delivering the Whitebox, and the customer who is going to activate it and use it, and the device, what the device has to do when it boots up for the first time, and what is the role of managed service providers like Verizon. So when a OEM is shipping the device for the first time, he will make use of the TPM and then generate the public and private keys. And he has to upload that public key to Verizon's inventory, giving that this is the serial number of the hardware, this is the MAC address, and this is the public key associated with it. And he will bake in required software modules and any day zero configuration required. He would bake that into that hardware and ships it. So now the customer gets it, and customer would have to just do the plugging, cabling the box and attaching the power to it. So when it comes up, it knows the day zero configuration. It knows where to call home our MSP stack. So controller, so the connection goes there. And then, and then the agent that is running in the device is also going to calculate the, does the MD5 checksum of the file system and get the TPM-related data and also publish it to the control stack. And our control stack will do the signing of that CSR request from the device and push back the certificate to the device. So device now has a trust established with our control stack, and so all the connection that is going up from that time onwards is fully secured. It will be an HTTPS connection instead of simple one-way authentication with HTTPS. So with this, we were able to get a secure bidirectional communication between the Whitebox and the control stack. So what it enables, why do we need the bidirectional communication again? So it's not only commands that are being pushed from the MSP stack onto the Whitebox or onto the VNFs. So VNFs needs to push events, alarms, and usage information asynchronously to our platform. So this enables, if you go with WebSocket-based connectivity, secure web WebSocket connection between Whitebox and the MSP stack, it enables that bidirectional communication. So we can use the same certificate that MSP has signed. The Whitebox can create a IPsec tunnel. If the WebSocket is not the way to get the connectivity, it can go with IPsec tunnels as well. So it's a flexibility. We can think further as well. We can ensure our control stack IP addresses are not visible to the device itself. With WebSockets, it's quite possible. We can make believe these VNFs that they are connecting to a local IP address with a different port. So all the services can have a different port on 127.0.0.1, and VNFs, if they want to communicate with our stack, they think they are making a local connection. This way, this connection is going through the secure WebSocket tunnels, and we have the access proxy, which knows based on the destination port, which is the right service to send the message for. So, so this is like your software-defined perimeter. If you have known SDP, that's what it does. It is hiding your the servers as if they are in the dark zone, and nobody can guess the actual IP address of that servers. So this is one way of achieving SDP-like behavior. With our agent running in the Whitebox, we can get more insights into the Whitebox, what VNFs are running, and is there any breach? Did anyone log into the system? We can run Linux audit tools and send that logs and alerts back to the control stack for analysis. And if anybody has installed a new VNF without our knowledge, we can get to know, because we do that integrity check all the time and ensure there are no breaches, or if it's hacked up, then we remove it from the system. So those are the benefits we get with our agent running in that. So most importantly, we are able to make sure there is a trusted communication from MSP stack to the Whiteboxes. And as I said, even if the Whitebox is falling down from the truck, he hooks up the power. Still, he cannot do much with it. So this is how we have implemented that. Thank you. Any questions?
So any questions from the audience for Ravi? So one thing is, I mean, is this actually in deployment, or is this something that's been figured out and it's going to be in imminent deployment? What's the status of?
So this is in deployment. That's how we are able to get at scale deploy several VNFs at distributed locations in few hours. So some of the aspects like the TPM enablement or some of the aspects may not be available right now, but with the zero-touch provisioning, all the 4 steps that we mentioned, we are able to achieve that.
Excellent, excellent. All right. So
Tim DeWaren from ACG Research. My question is, how much are you mixing and matching VNFs today versus tending to make them more homogeneous from a single vendor? And I just wondered how challenging that was or wasn't. Thank you.
So if I understand your question correctly, were you asking how many vendors we have with the same category of the VNF? Is that the mixing?
Yeah, I was wondering in any given deployment how homogeneous or heterogeneous it was in terms of the number of vendors, types of VNFs being deployed at any given customer. Thank you.
Yeah, we do have quite a wide variety of VNFs. Actually, in last year's Layer 1 to 3 session, I covered how we were doing VNF onboarding. So we developed a framework where vendors can come up and upload their VNF images, and we have an automated fashion of evaluating that, even raising tickets back to the vendor if there is a performance issue, reporting back. And we have an automated fashion, not just for VNF testing, but the entire service level testing. You can, with the blueprint that I was talking about, let's say the customer wanted a service with the VNF 1, VNF 2, VNF 3. right? So we take that chain and then put it in a sandbox, and we do all the types of testing, both functional as well as regression, to make sure that chain is working before we push it onto the actual hypervisors or white boxes.
Sorry, just one more follow-up, which is, how about the service assurance side of that once you get that deployed with multiple, say, different vendors and VNFs? Is service assurance as easy as we used to have it with physical instances of things, or has that been a challenge, or how is that from a maturity, you think, from where you are in your deployments? Thank you.
That's a good question. Actually, we have that complexity of VNFMs. Every vendor has their own element manager or VNFM, and if we can go that route, so the event is captured, the responsibility of the monitoring is going to the VNFM, and it is feeding us the event. That's one way of doing it, and we have mix. So we go with the vendor-supplied VNFMs, we go with our own proprietary implementation, generic VNFMs, to gather that event, and we have created autonomic functions to make sure we have a separation, vendor agnostic models and vendor specific models. So you have multiple vendor specific implementations like vendor 1, vendor 2, handling the events from their devices. And if that's not being handled at that level, it goes to the next level where we have vendor agnostic model to act upon. For example, this is a theory, but it's not implemented. If there is an issue with vendor 1 VNF, we can replace that with vendor 2 VNF, because we have an abstracted data model all the way to vendor agnostic and configuration-wise as well as monitoring-wise.
Thank you. All right. Any other questions for Siva? I'm sorry, Ravi.
This Shri for Verizon. Just not question, just comment on the number of VNFs which you are talking about. We have few vendors on that, there are 5 categories we have, like security, WAN optimizer, SD-WAN, so on and so forth. On similar one, service assurance piece, what we have done the closed loop assurance for few use cases, scaling up and down, and then recovery flow and all those things. And it is like vendor agnostic again, like orchestrator kind of partnered with a third party service assurance tool, and then they did that. Sure.
There's one more here.
I know Verizon is a member of ONAP. Is that right?
Yeah, that's correct.
Or a member of some other projects. So I'm wondering, this part of the work, is that going to either part of those projects, or you plan to push it into those projects? Because how the other operators or vendor benefit from your design? That's my question.
So that's a good question. So Verizon joined ONAP very recently. And even before we have joined, we have created all this ecosystem. So this is pretty much in-house built. And the second part of the question, if we have plans to open source or push into the community, this is a bigger strategy question. So I will skip that.
All right. Well, great. Thanks so much, Ravi. Really appreciate all the
Thank
time, answering the questions.